In this video, I'm going to talk to you about Ansible's declarative intent idea, which was introduced in Ansible 2.4. And this idea, I think, is confusing. It's another one of those ideas that is now in a state of limbo, because basically there were several objections raised to the idea and the way it was implemented. And it was realized that there was probably going to have to be some redesign work. So this declarative intent modules are now in this limbo state where going forward, they're not going to probably be added into modules any longer. I think they're going to take a different tact for trying to implement this in the future. But let's look at the idea, let's discuss it, and let's see what's potentially useful from it. There were a set of modules which had these capabilities added to them. So in Ansible 2.4, 2.5, you can potentially look and see if there's something useful in the modules that implemented this. Okay, so let's talk about the general idea, and let's also talk about the areas where it presents confusion. So we have this module iOS interface, and with the iOS interface module, you specify an interface. Here we're dealing with interface fast Ethernet 0 that we're going to configure. And then we specify other aspects of it. So here I'm just going to set a description on that interface. Now, historically, this state would be either set to present or absent, meaning that interface has to be there or the interface has to not be there. And the idea behind the declarative intent was basically to say more than just does the interface need to be present in the configuration or not. The idea was basically to say, does the interface reach that state? So for example, let's look at fast Ethernet 4. So I'm going to comment out the neighbors here. But you could say with this, not only do I want this interface to be present, to exist in the config, but I want it to reach the up state. So I want to ensure with my playbook, not only is the configuration state correct, but the operational state is correct. So it's cabled to whatever it needs to be cabled to, and it's reached the proper end state. So it's basically a combining of configuration state and operational state. And that was actually where most of the objections to this declarative intent idea were around. That this notion of state was conflated between two things. Those two things being the config state and the operational state. And that was overloaded with these two different meanings, which was basically going to start causing a lot of confusion and potentially issues. So if we run this playbook, what's going to happen? So on this first task, it's going to go and make sure that fast Ethernet 0 exists on PyNet router 1. It's going to make sure the description is set to this, and it's going to ensure that the state is actually in a down state. And fast Ethernet 0 is actually not cabled, so it will in fact be in a down state. And also it'll ensure that the port is enabled so that no shutdown is executed. In this situation, it's going to ensure that fast Ethernet 4 has this description and the state is an up state. So looking at the router, if you did a show interfaces on it, it's going to be flagged as up. So we'll go ahead and execute that and see what happens. Okay, so FA0 is correct, FA4 is correct. Now let's go ahead and look at one other thing with this interface. You could also potentially specify the LLDP neighbors. So not only does the port have to be up, but in LLDP, it has to correspond to this. Now I was running into an issue where for some reason this port is not working, even though LLDP for the remote port is showing this descriptive, this declarative intent statement is not working. and it's always flagging me as an error in that situation. But the intent of that was to say that you could specify what's supposed to show up in LLDP, and for some reason I'm running into an issue where that module looks like it's not working properly. Okay, let's look at another example of this. So we were looking at EOS VLAN earlier, and we saw how we could configure VLANs. Now, we also saw using the interfaces argument how you could associate interfaces to a VLAN. But what if you didn't want to just associate interfaces? What if you wanted to actually verify that those interfaces belonged to the VLAN? So with the current config, both Ethernet 6 and Ethernet 7 should currently be assigned VLAN 403. So this is going to verify that these interfaces belong to that VLAN. It'll also ensure that VLAN ID 403 exists on the switch and that its state is present, which is the same as what I already said, that that VLAN exists on that switch. Okay, so let's go ahead and execute that. Verify that it executes properly. Then I'll toggle in that EOS VLAN. I'll go ahead and toggle that Ethernet 5 port, and I'll show you what it looks like when it fails, because Ethernet 5 is not currently bound to VLAN 403. Go ahead and re-execute this, and then I'll show you the failure situation. Okay, and there we see that it actually reports to us interface Ethernet 5 not configured on VLAN 403. So it actually tells us what's wrong, which is nice in that scenario. So the general idea of declarative intent is that you're trying to specify more of the end state that you want your device to reach, and end state has both configuration state embedded in it and operational state embedded in it.